Hemisphere's primary focus is on delivering high precision GNSS technology and integrating that technology with other solutions in order to deliver a high value product to our OEM customers and our channel partners. So we've really, over the last number of years, as we get ready to come to market with this new solution, we've been focusing on putting together a solution that really hits a price point and a value proposition that allows new markets, new equipment sizes to actually be able to justify the cost.
Our Phantom and Vega series boards improve on our previous generations of hardware as they're based on our new Lyra 2 ASIC technology. Our new ASIC technology platforms allow our GNSS receivers to track all of the new available future and modern GNSS signals. So that's including signals like GPS L5, Beto Phase 3, all the Galileo E6 level signals, and we can even support options for QZSS, IRNSS, and again, all of the current and forthcoming modern signals. So this gives our customers and our user base an exceptional access to all of the new technology that we currently have and what we know is coming on the horizon for their positioning solutions. How does the ASIC work? The Lyra 2 ASIC works, it basically provides access to all of the available modern GNSS signals to where we can actually do the tracking and signal processing all within the actual digital ASIC rapidly. And it gives us the ability to minimize and reduce a lot of the tasks that were performed by discrete components are now all being done within our ASIC, which basically gives lower power consumption, higher performance, in a much smaller form factor and package. These new generations of receivers will also incorporate new interference mitigation technologies because we've discovered, and as the evolution of GNSS positioning solutions has grown, threats from outside sources or interference sources and having the ability to mitigate those threats in real time is a true need and a desire from the positioning market.
Cygnus gives you a capability that you've not had before. You have this ability to adjust or change your receiver bandwidths out in the real world, and you also have an ability to look at the spectrum right there. You don't need test equipment. You don't need to have a spectrum analyzer out there. It's all built in to the little tiny digital ASIC that's very small, low power, and you get very good resolution on that. So you can see what your receiver sees. And if you think you have problems with your receiver because of interference, you can look at that immediately and you'll know if there's a problem with interference. But that's the important thing, is you can adjust the receiver to work in different, more harsh environments than what you've worked in the past.
One of the major differences between this generation and previous generation is now we separate the signals digitally. We used to do it in the RF, and by separating them digitally, we basically have reduced part count on the boards where we're using almost half the parts. We are using a lot less power now because we use fewer RF down converters. We have a new technology that allows us, we basically can track now every signal in the sky.